All right, I will just tell you right now that this section represents one of those where you're going to have to pay attention in class because this doesn't show everything that's on the MathXL, but I can cover it in class, and you can always email me for assistance. Just make sure you attend the Zoom meeting to get what you need. But exponential functions is what we're talking about in 7.6. Exponentials are functions in which the x variables in the exponent. So we had y equals 2x plus 1. That's not the exponent. That is linear. Anytime the x is being multiplied, it's what we call linear. But whenever the x is up here, a times b to the x is the general format. This is the initial number, and this is what we call the growth factor, which we'll talk about later. What is the difference between exponential and linear? Well, the main difference, there are two. First off, the variables in different locations. So y equals 3x is right next to the x. Y equals 3 to the x. It's a smaller x, and you have to kind of train yourself to make sure you're ready for that. Secondly, the graphs look different. The first graph, 3x, looks like a line. As I said, it's linear. 3 to the x looks like an airplane taking off. At least that's how I visualize exponential functions. It's either airplane taking off or an airplane landing. So again, that's what you need to be careful about for that. All right. So in the general format, which is a times b to the x, a is what we call the starting value. You need to know that. It's your starting value. And b is your growth factor. In other words, how is the initial value changing? The growth factor is determined by adding or subtracting the percent change from 100, or considering doubling, tripling, and so on, which I think is one of the problems that is on your work, but we'll talk about that. Or like I said, you can email me and I'll be glad to discuss it with you. Just make sure you are ready to talk. Again, I don't mind responding to your emails, but be clear about what you need so that I can get you an efficient answer. It is best to see this in action, so again, let's just take a look. It says a population of 500 animals decays at an annual rate of 19%. How many animals will there be in 4 years? So first thing it's going to ask you to do is to write a formula. Remember I said that A is your initial value. There are 500 animals right now, so your first number is going to be 500. Maybe you want to even label what each part represents. This would be your initial value. And then B is your growth rate. Well, here's what growth means. It means how is it changing? If it's decreasing by 19%, you don't put 19% in there. What you do is say, what is the natural amount? Well, 100% is your natural amount. 100 is everything. So if something decreases by 19%, that means it's decreasing from 100 by 19%, which means your growth factor is 81%, which is 0.81, and then to the x. This is your formula, and that's the first box you're going to have to fill in on this problem. But again, the 81, and you might want to do that, came from the fact that 100% minus 19% equals 81%, which is where you got that number from. And again, we subtracted because it decayed at that much. After that, how much is there after 4 years? Well, x is your time, so you simply put 500 parentheses 0.81 to the 4th power. And typically, I believe you round it to the nearest whole number because, again, it's animals. You're not going to see 0.2 of an animal. So 215 would be what I end up with. But again, you might miss that. Just make sure you try to figure out what you missed and if it was your mistake or if it was just a mistake with me and my programming, and then just try another one and answer it. Because, again, it doesn't take that long to actually figure out how to redo it. Just make sure, again, you have good notes on this problem. This is different. Population 350 increases at a rate of 11%. How many animals will there be in 6 years? Again, initial value. So 350 animals. Increases at 11%. Again, your increase decrease is based off of 100. If it increases, that means we are adding 11%, which means we have 111%. Remember, you move the decimal 2 spots, which makes this 1.11 to the x. Again, it added 11%. That means 100% plus 11%, which makes sense. But again, the hard ones are going to be the decrease and making sure you read the directions. The next thing it says is how many will there be in 6 years? Just type it in. Parentheses 1.11 to the 6th is, again, round this. I think it'll be 655 because that 6 bumps it up. And that'll do it. All right. This does say the last topic, but again, there are other questions that I'll show you in class Tuesday, Wednesday, actually Tuesday, Wednesday. But again, to graph an exponential function, follow 2 steps. First thing you want to do is create a 5-point chart. You have to use -2, -1, 0, 1, 2. Not on all of them later on, but right now in terms of this book for your introduction, it's always going to be using x equals these 5 numbers. Then plot the points and graph the following pattern. All right. So exponential graphs either look like an airplane taking off or an airplane landing. Jot this down. So it's either going to look like this when you consider this is the ground. It's on the ground, it starts to take off, and it's not really taking off, it's flying to the sky, but that's one. Or it's going to look like an airplane landing, which means it's going to kind of do this. The thing you have to pay attention to, again, it's coming down, it starts to go, and it lands on the ground. The thing you have to pay attention to is it should not go through the ground, because an airplane that does this is not going to fly out of the ground. An airplane that does this is crashing, because once it hits that line, it's going to blow up. So just make sure that you understand in terms of the exponential graph, it should not touch the line, but it should look like one of these 2 things here. As long as you remember those 2, you will see that your points will tell you what you need to know. All right. It's not hard to figure out which one's which just by creating the 5-point chart. So what we do here is make our 5-point chart. Again, -2, -1, 0, 1, 2. We like to center around 0 because that's where most of the information goes. So 4, parentheses, 1.21, caret -2 is 2.73. And yes, you do want to go, I believe, to 2 decimals, I think. But again, adjust. If you want to find out for yourself, just miss the problem and see what it rounds to. And then what I'll do is go here, turn that to -1, which is 3.31. Zero delete is 4. 1, which is 4.84. And 2, which is 5.86. When plotting this, -2 is 2.73, so 2.73 is pretty close to 3. -1 is 3.31, so 3.31 would be slightly higher than 3, but again, not hitting 0.5. You don't have to be perfect, you just have to have an idea. 0 is at 4. 1 is at 4.84, which is pretty close to 5, so it'd be somewhere around here. And 2 is at 5 point something, 1, 2, 3, 4, 5.86, which is pretty close to 6. Now again, if you can't look at those and recognize the airplane's taking off, there's an issue. So you would just draw your best representation of a line going through here. There you go. Or it's multiple choice and you'll see that graph and know what you're doing. But again, it should not go through the ground because no airplane is going to go through the ground or come from the ground in our math so far. That's it. 5-point chart is made by using -2, -1, 0, 1, and 2. So a 5-point chart again, X and Y. Again, -2, -1, 0, 1, 2. I would just put those in the boxes first, and then you go through and fill in your numbers. So 6 parentheses 0.84 to the -2nd is 8.5. Actually 50, but they usually don't put the 0. -1 is 7.14. You can actually see what the numbers are doing because these numbers went up, which is taking off. These numbers are going down, which means it is probably going to be landing 0, delete, and 0, 6, 1 is 5.04, and 2 is 4.23. So when we go to graph this, again, -2, 8.5, 1, 2, 3, 4, 5, 6, 7, 8, 9, about 2.5. Again, I don't need it to be perfect, just around the area so I can get a visualization of it. -1, 7.14, which is pretty close to 7 because it's 7.1. 1, 2, 3, 4, 5, 6, 7, just barely above 7, back to here. 0, 6, 1, 2, 3, 4, 5, 6. 1, 5.04, 1, 2, 3, 4, 5, just barely above 5 because it's 5.0. And 2, 4.23, 1, 2, 3, 4, again, somewhere around here. And again, you should be able to see this airplane is going down. And it doesn't curve a lot, but again, what you should be looking for is something that has a little bit of a curve because it's not linear. But again, a graph that looks something like that should not be going through here. Again, if you see it going through, it's wrong. That's the key idea. All right. The majority of those rest of the problems just require your ability to plug values into a function and evaluate using your calculator. You should be able to get most of it done with just that. But again, make sure that you attend these Zoom meetings so you can see the other ones that are in there, ask your questions that you need to, and work to understand it. I don't think it's tough. I think it's just something that you have to actually care about to do well. So again, hopefully you show up to these Zoom meetings or in class. For those of you actually know, it's the class. But again, hopefully you show up and take care of that. But other than that, good luck. I'll talk to you later.